Hi there. It's time for algebra. Just thought I'd pop in and say howdy. Howdy. Let's get to today's lesson. I don't think it's going to be too long. And then I will also, after the lesson, if you want to hang around, I will go through the problems and kind of give you some hints, some clues, some tips. And you never know. Sometimes I'll even give an answer. But let's see what our lesson holds for today. Okay, we are looking at quadratic equations with irrational solutions. Irrational numbers. What's an irrational number? Well, it's irrational. It just throws off, goes crazy, flies off the handle when the slightest thing happens. No, that's not what I'm talking about being irrational. Remember, a rational number is any number you can write as a fraction. 2 over 3, 8 over 7, 14 over 6, 2, 0, -1. I mean, there's lots of numbers like that. Irrational numbers are like the square root of 2. We can't write that as a fraction because it's a decimal that just keeps going on. Square root of 5, different things. Pi. There's lots of irrational numbers. So we're going to look at quadratic equations that will have solutions that have irrational solutions. All right, let's start with looking at some squares. All right. Here are some squares whose vertices are on a grid. So the vertices are the corners, all right? That's the points that the square turns at, and they're all right there on points. Find the area and side length of each square. Well, side length, we gotta have that before we can do the area. So let's make sure I'm still in focus there. Let's start with square A. A is pretty easy. How long is the side? It goes from here, it goes 1, 2, 3. It is 3 units. Do I need to measure them all? It's a square. They're all the same. It told me it's a square. If I had to check see if it's a square, then I need to see how long the other sides are. But these tell me here are some squares. Don't need to check. So what is the area? Length times width, right? Side times side. Area would be 9 square units. Okay, A was real easy. Now they're going to turn our life all around here. Let me just turn it and measure. That's just 1. No, that's not correct. This is a diagonal. This is a diagonal. So we have to make a right triangle and find the hypotenuse of that right triangle. This length is 1. This length is 1. How long is that? Pythagorean theorem, right? 1 squared plus 1 squared equals c squared. What is 1 squared? 1 times 1? 1 plus another 1, c squared. So 2 equals c squared. So if 2 equals c squared, what is c? How long is that side? It is the irrational number, the square root of 2, which is a long decimal that keeps going. Square root of 2. So what is the area? Well, if this is the square root of 2 and this is the square root of 2 and that's the length and the width, square root of 2 times the square root of 2 is 2. I like how that works. Square root of 7 times the square root of 7, it's 7. Square root of 109 times the square root of 109, that's 109. When you take a square root of the exact same number and multiply it by another square root of the exact same number, you just get the number because it works wonderfully that way. And think of that. You're like, does that really work? Sure. What is the square root of 9? Well, we can say 3 or -3. Conventionally, if you just see a square root of 9, most often they're talking about 3. That's conventionally what we talk about. But we do know that -3 is another answer we may need in certain situations. But square root of 9 is 3. So what if I take that square root of 9 times the square root of 9? 3 times 3. I get 9 again. So yes, it works all the time. C. Again, right triangle. Try not to take too long. That's 3. That's 1. So 3 squared plus 1 squared equals c squared. 3 times 3 is 9. 1 times 1 is 1 equals c squared. So this is the square root of 10, right? So what is the area of this right here? And we can count it. 1, 2, 3, 4. There's a partial box. There's a partial. No, we don't want to do that. Square root of 10 times square root of 10. 10 square units. All right. Let's move on. All right, solutions written as square roots. Solve each equation and use the plus or minus notation when appropriate. Now, I will tell you, your homework starts out tonight with use this where appropriate. And that button exists. On your homework assignment, I actually put a little diagram showing you where that button is. So when you go to enter your answer, hit the little keyboard, and there is the plus minus. So if you need to say it's plus or minus 4, hit that plus minus button and 4. And that's the answer. And that's what the computer is going to look for. If you type plus / minus 4, the computer is going to go, what? That's wrong, even if it's right. Right. So use the plus or minus symbol that the computer itself has built into it. All right, let's solve these. We got an x squared and a minus 13. We need to move that 13. So we will add to both sides. X squared equals 1. All right? Negative 12 plus 13. So what does x equal? If x squared equals 1, we need to take the square root of both sides. So x equals, there's that plus or minus the square root of 1. That's the same as saying plus 1 and minus 1. Or minus 1, really. X could either be 1 or it could be negative 1. But this is a shortcut. Just say plus or minus 1. And what is the square root of 1? Well, that's the square root of 1 is 1. So we don't have to even write the square root of 1, even though it's the same number. Simplify it. Square root of 1 is 1. 1 times 1 is 1. So plus or minus 1 is our answer for that. This one right here, x minus 6 squared equals 0. So let's see. That means x minus 6 equals 0, or x minus 6 equals 0, right? So if we take the square root of both sides, that would be x minus 6 equals plus or minus 0. Do we do that? No, there's not a plus or minus 0. Add 6, add 6. So x equals 6. That's the only possible answer for that one. X minus 6 squared equals 0. Just one solution. This one had two solutions, plus 1 and minus 1. This one has one solution, just 6. Because any other number would not make that 0. And it needs to be 0. X squared plus 9. Let's do this. All right, well, we got to get rid of this first. X squared equals negative 9. So up here, we needed a number that would multiply by itself to be 1, which we said could be 1 or negative 1, right? Either one of those would get us there. 1 times 1 is 1. Negative 1 times negative 1 is 1. Here, we need a number to multiply by itself to be negative 9. Can you think of one? I'll wait. No, that'd be a long time to wait. There's not one, right? We cannot multiply any number times itself and end up with a negative. Because if we choose a positive number, multiplying it by itself is not going to be negative. If we choose a negative number, then we're multiplying a negative times another negative. And that's going to be positive. So, no solution. Right? There's not a solution for that. X squared cannot equal negative 9. Because whatever number we take and we square it and then we add 9 to it, we'll never get 0. So, x squared equals 18. Okay? So, all we do is take the square root. So, x equals plus or minus the square root of 18. That's not a whole number because 4 times 4 is 16. 5 times 5 is 25. So, it's somewhere between there. It's a 4 point something. That would be 18. So we'll write it like that. X is plus or minus square root of 18. All right. X plus 1 squared equals 18. Okay. Square root of both sides. This is a little different. Stay with me. This is squared. And so it's just like that one, but we got this plus 1 in parentheses. So what we're going to do is take x plus 1, because we're taking the square root, equals the plus or minus square root of 18. We're not there yet. We don't have x equals. Subtract 1. So x equals plus or minus the square root of 18 minus 1 more. Right? We could have wrote it with the 1 in the front, negative 1 plus or minus the square root of 18. These are the same number, right? Plus or minus the square root of 18 minus 1, or minus 1 plus or minus the square root of 18. But that's as close as we can get. It's going to be plus or minus. It's going to be a 4 point something or a negative 4 point something. And then we're going to subtract 1 more. So if it's a 4 point something, we subtract 1. One of the x's is 3 point something because we subtracted 1. If we choose the negative square root of 18, negative 4 point something, subtract 1. The other x is going to be a negative 5 point something. So you'll see answers either direction on that. So let's look at one where you find irrational solutions by completing the square. Okay, and this is already done. We're not completing the square on this. Here's an example of an equation being solved by graphing and completing the square. So here they just graphed it. And what did they see? Negative 1.586, rounded to 3 decimals, comma 0, is where it crosses right there. So that's one solution, because that's where it crosses the x-axis. The other one's negative 4.4140. That's the other solution. Neither one of those solutions are very nice whole numbers that we usually work with. So here's the equation for this graph. X squared plus 6x plus 7. So here's what they did. They said, okay, this is not a perfect square because we have a 1 in the front. So we just take this in half, 3. 3 times 3 is 9. This should be a 9 for it to be a perfect square, right? Because we cut that in half and then take it times itself. So they said, all right, I need it to be a 9 and then it'd be a perfect square. So they added 2. And they added 2 over here, right? If we can do that as long as we do both sides. I'm going to add 2 over here. I'm going to add 2 over here. We're good. So x squared plus 6x plus 9 equals 2. Now this is a perfect square. It's x plus 3 times x plus 3 because we made it that way by adding 2. X plus 3 equals 2. So then it gets to what we were doing on the previous page. Take the square root of both sides. The square root of that's just 1x plus 3. Square root of 2 is plus or minus the square root of 2. All right. To get x, you have to subtract 3 from both sides. So it's minus 3 plus or minus the square root of 2. So let's verify. Let's verify that the graphing and the equation both come up with the same thing. The square root of 2 is approximately 1.414. Okay, it continues past that, but rounding it off, it's approximately 1.414. So if we use the positive square root of 2, positive 1.4. So the answer was negative 3 plus 1.414. That would be negative 1.586. See how that works? Negative 3 plus the 1.414 is that. If we use the minus 1, because that's the other answer, minus 3 minus the square root of 2 is 4.414. We took the 1.414, we subtracted from negative 3, and it put us even farther back. So this is the two answers. And what do you know, when we graphed it, that was the x coordinates of where the graph equals 0. So that was the solutions, 1.586 negative and negative 4.4. All right, so you see how that works? Graphing it gave us the answer also, but we don't always have the ability to graph things. So we need to be able to find it algebraically, using algebra, using the math, using the equations to solve it, which is what we did over here. All right, so now we're going to try 2. It says, for the equations, find the exact solutions by completing the square and the approximate solutions by graphing. Again, this is approximate. This is exact. This is not rounded. Now, we rounded it to check the graph, but square root of 2 is not a rounded number because it continues on. If you change it to a decimal, it becomes a rounded number. So I'm not going to graph these. You can go to desmos.com like we've done before, and you can graph these and check these solutions. But I'm not going to do that. I want to do it algebraically because that's the way we need to understand. We know how to graph. We can type an equation in and look at a graph. We know how to do that. Let's complete the square. X squared plus 4x plus 1. Now 4x, if we take half of the 4 is 2. 2 times 2 is 4, so this needs to be plus 4. So we need to add 3 more to it, which means we need to add 3 over here. So our new equations will be x squared plus 4x plus 4 equals 3. All right. So now this is a perfect square trinomial. We can break it into two binomials that are exactly the same. X plus 2. We found that by cutting that in half, right? That gave us the 2. And then we went 2 times 2 to get the last number there. Squared equals 3. So square root of both sides. So x plus 2 equals the square root of 3. 1.7 something. Continues. So we have to subtract 2. So x equals, oh, I forgot my little symbol already. Plus or minus. Plus or minus the square root of 3 minus 2. Plus or minus square root of 3 minus 2. That is the exact answer. And if you graph it, you'll find that. If you use the positive, it'll be like 0.2 something is where it crosses the x-axis. If you use the minus one, it'll cross at like negative 3.7 something on the x-axis when you graph it. So that is the same number, just approximate. The graph is approximate. So we want the exact solution. So if it asks for exact solutions, you need to do this because this is exact. Graphing is approximate. It's not the same. It's very, very, very similar, but not the same. So look for that exact. Exact. Let me highlight. I'm going to highlight exact because that means something. All right, let's look at this last one real quick. And then this will be the last problem that I'm showing you. And then I will show you the homework. We'll go through it. We'll look at it. I'll give you some tips and hints. And, maybe an answer if I get to something I want to give an answer. We'll see. X squared minus 10x plus 18. So we know x, we take half of this. It's going to be x minus 5 squared. But that means this number should be negative 5 times negative 5, which is a positive 25. So we're going to add 7 more on there. Add 7 on both sides. So if that was a 25, then it would go to this. All right, so it'd be x squared minus 10x plus 25, which is the same as this in factored form, because the two factors are x minus 5 times x minus 5. And that is going to equal 7 now, because we had to add 7 to both sides. So take the square root. X minus 5 equals plus or minus the square root of 7. All right, plus or minus. So we're going to add 5 to both sides. So x equals plus or minus the square root of 7 plus 5. Or, if you like, it's the same thing to say it's 5 plus or minus the square root of 7. Right? That may be easier to think about. I take 5 and then I'm either going to add the square root of 7 or I'm going to subtract the square root of 7. This one, if you rearrange it, remember that 2 is negative. Be negative 2 plus or minus the square root of 3. So you can put those in either order. It's exact same answer, either order. So that is that. Let me show you what your assignment is today. We've got a few problems here. All right. Here is where I'm showing you on your answer. If you hit this little keypad, it'll open up this box, and I'm sure several of you have used this box before. But right here, there is the plus or minus button. It's right there, so you can hit that for your answer. Solve each equation and write the solutions using this notation. All right? Yes, there's a button for this. It's right there. So x squared equals 144. What number multiplied by itself is 144? All right? Plus, minus. You need to hit that plus minus button first. And what is 12? I'll give you that one. Plus or minus 12. 12 or negative 12, either one. So that would be what you need to have in that first box, and the computer be happy. So each of these is the same thing. Get a little harder. This one you need to divide by 4 first. All right. This one you need to divide by 2 first. Divide by 7 first. And you'll get to a fraction there, but that's okay. You can always put a square root of a fraction. 3 halves. This is not 3 halves. I'm just saying that. You can put a square root of a fraction. And you do have the square root button that you can use right there. And this is a fraction button right here. This is a fraction button. So if you want to type in a fraction, you can use that button. So, all right. After you do these, then you have a matching. Okay. Match these with the same expression over here. 4 plus or minus 1. Well, if it's 4 plus 1, what's 4 plus 1? That's 5. Is 4 minus 1? That's 3. So which one of those does it have to be? Oh, look. A goes with 4, because 4 plus or minus 1 is the same thing as 3 and 5. Okay? Matching. That shouldn't be too bad. All right. Here's one I need you to explain to me. Jada is working on solving the quadratic equation shown. So here's her equation. P squared minus 5p equals 0. Okay, pretty simple one. She says, I'm going to factor out the p. There's a p in both terms. So p times p minus 5. That is the same thing as that. Okay, all right. We're good there. P times p minus 5 equals 0. So then if I set it equal to 0, p minus 5 equal to 0, p has to be 5 because I add 5 to both sides. All right, she says she thinks her solution is correct because if she puts a 5 back into there, 5 squared is 25, minus 5 times 5 is 25. It does equal 0. So she says, all right, I am correct. The answer is p equals 5. Okay, is Jada correct that there is one solution to this, and it's p equals 5? If so, explain why we only have one solution. Because most of the time with quadratics, we have two solutions. Most of the time, right? A lot of times we do. Or say, oh, nope, she missed something. There is a second solution, and it's this. So, all right. So that's just one where you answer one way or the other. Just look at that. And again, you need help with any of this, Miss Smith and I are online. We'll help you with these problems. These are all assisted, and we're happy to assist you. So, and the last one is a multiple choice also. So which expression in factored form is the same as this? Okay, so if you multiplied these two together, would it be that? Or would I have to multiply these two together to get that? Which one of these would multiply together to get that? Key things to look, and these all seem to have that. 6x times 5x is 30x squared, but they all have 6x and 5x, except this one has 10x and 3x. Well, that's still 30x squared. 30x and 1x, that's 30x squared. So those are all right. 5 has to be 5 and 1. Those are all 5 and 1, so that doesn't tell anything. Right here is the key. Which one of those will give you 31x as the middle term? And if you need to draw a box and say, I want to put 10x and 5 and 3x and 1 and multiply them out, then do that. Do that if you need to. All right, that's all your problems. We will catch you next time, and do work you can be proud of.